Let us now continue with the working of the AC generator. So we are just in the continuation with the working part of the AC generator. We know at theta equals to 0 degrees, flux is maximum, and theta equals to 90 degree, flux is minimum. And through this criteria, we can say change in flux is maximum. So change in flux is maximum. And if there is change in flux, then due to electromagnetic induction, current would be induced in the coil. So we are not making the diagram for theta equals to 0, that we have already made. So now we are starting with theta as 90 degrees. So this is the north pole, this is the south pole, this is the armature. These are the brushes which are present, the slip rings, and to these slip rings there are brushes which are being attached. So let me name these brushes as B1 and B2, and it is connected to the external circuit, which is the load. Alright, this is the axle, and there is soft iron core which is present in between. Now at this position, AB is over here and CD is like this. At 0 degree, that is the case before this, flux was maximum. At this case, flux is minimum. Change of flux is maximum, so that is why an induced EMF will be produced here. That will give us the direction of the flow of current. Now, in order to apply that thing, we'll have to use Fleming's right hand rule. So here we are applying, let me write it here, Fleming's right hand rule. If you remember, we have rotated this armature in the clockwise direction in such a way that if it was like this, the AB will move out like this. It will move out. So it is coming clockwise. So at this position which is theta equals to 90 degree, it will again continue to move in the clockwise direction, means in the next rotation it will turn like this. It will turn like this in the clockwise direction. It will turn like this. So it means AB is moving out and CD is moving in. AB is moving out and CD is moving in, because the couple, or we would say the torque is acting. Why torque is acting? Because a couple is present there. Couple is two similar forces which are equal in magnitude but opposite in direction. On the arm AB, the force tends to make the AB to move out and CD to move in, so that it will continue its motion in clockwise direction. So on arm AB, it is outwards, force is outwards, and on arm CD, it is inwards. At this position, it is inwards. So this is outwards and CD is inwards. Force acting on AB is outwards and on CD is inwards. Alright. Now, magnetic field is from north to south. That is always the criteria. North to south like this. AB out, CD in. So let us apply Fleming's right hand rule. Magnetic field in the direction of the forefinger, then out. Thrust is outside, means this thumb has to be pointed outwards, that is towards your side for arm AB. Current is bottom to top. Current is bottom to top, means it is acting upwards. So current is moving upwards in the arm AB. Alright, let us consider arm CD. Now again the field is left to right. In CD, this thumb is pointed inwards. This thumb is pointed inwards. And the direction in which the central finger is pointing is top to bottom. It means from upside down. Alright, so let us see. This is the direction of flow of current. So current is flowing through this, like this, it will pass through the load and again will enter the circuit like this. Alright, so the direction of flow of current is from, externally it is from B1 to B2. Externally it is from B1 to B2. Direction of current externally is from B1 to B2. This is the direction of the flow of current B1 to B2. Now, what is happening at the next case, theta equals to 180 degrees. This is 90, 180 degree flux is maximum, but change in flux is 0 because we'll have to consider it with this case. So at theta equals to 180 degree, no flux is, no change in flux is there, so no EMF would be there. So we are just skipping that portion to 270 degrees. Theta equals to 270 degree. At theta equals to 270 degree, this is again a magnet. This is again a magnet. There is the armature like this. Now, at this case, at the case of 270 degree, the arms would be interchanged. As we have seen, AB will move here, CD will move like this. There is the soft iron core which is present, and this is the armature, axle. Alright, by visualizing this, we are completing the diagram. AB is the longer arm towards left hand side. So AB is the longer arm which would now be turned right hand side. Alright, after its one rotation. CD is the shorter arm which is towards right. CD is still the shortest arm but towards left hand side. These are the rings R1 and R2. Brushes will not change their position. If here it was brush B1, it is still B1, and here it was B2, so still B2. So this is the external circuit, the load. Now, at theta equals to 180 degree, just before this case, it was like this. Alright, let us start from the beginning. Theta 0, theta 90, theta 180 degree, and when theta is 270 degree, again change in flux is maximum because it has become from maximum to minimum, so it means change in flux again is maximum. If there is change in flux, it means the EMF would be induced in this case. So now let us again see how it is going to happen. Now, at this position of 270 degrees, it will again continue to rotate in the clockwise direction. It will again continue to rotate in clockwise direction in such a way that CD will move out, just in the same case, CD will move out and AB will move in. CD will move out and AB will move in. Again, we'll apply the rule. Left to right is the magnetic field is left to right. Now, CD is moving out. Magnetic field is left to right, CD is moving out. Current is bottom to top. So, current is bottom to top like this. Alright. In AB, how could it be? The magnetic field is left to right like this, but on the AB, the torque is towards inside, or the force is acting towards inside. So, this thumb is pointing inside. Direction in which the central finger will point is the direction of the current, so it is top to bottom. So it is top to bottom like this. So this is the direction of the current. Now let us see how it flows in the external circuit. From this arm AB, it comes towards like this. This is the conducting ring. Through conducting ring, it will first pass through brush to this circuit and then to B1. And then B1 will conduct it through this to the internal circuit again. So from AB, it will move to this conducting ring to this wire and then to B1 through this conducting ring, and then it will enter the internal circuit again. So this is from B2 to B1. The current is from B2 to B1 externally. B2 to B1 externally. So when this is the position at theta 90 degree, the direction of flow of current was B1 to B2, but at theta 270 degree, the current is from B2 to B1. It means the current has changed its direction. Let us say if this is the positive direction B1 to B2, then B2 to B1 is the negative direction of the flow of current. So when theta is 90 degree, current is from B1 to B2. When theta is 270 degree, current is B2 to B1. Alright. We have to draw the another graph showing the formation of the AC current. So let me again erase some portion of the board and then we'll discuss the graph based on this observation. Let us now draw the graph based on this observation. So we are just drawing the graph of EMF versus this theta angle. Again I am dividing the angle theta 0 degrees, 90 degree, 180 degrees, 270 degrees and 360 degrees. When theta is 0, the coil is not rotating yet, so the amount of EMF or the current generated is 0. So this is the first point, starting point. When theta is 90 degree, current is maximum because this has brought the maximum change. Again, the current will start to induce the moment it will start to rotate at any angle. It means this is theta 0, then it will become 10, 20, 30, 40 and then it will become 90 degrees. So the current will start to induce, but the magnitude of that current would be small. At theta equals to 90 degree, when the change in flux is maximum, then only the EMF is maximum at theta 90 degree. The thing that I want to clear out is that this change is again not abrupt but slowly. The magnitude will increase slowly and at 90 degree it becomes maximum. So this is the maximum current. So the phase which is after 180 degree. We have seen the change in flux is not there with respect to the initial position. So the EMF generated would again be 0 at 180 degrees. At 270 degree, again the change is maximum. But from 180 to 270, the change is not abrupt. The change is maximum at 270 degree, but this has brought by a gradual changes. So again, at 270 degree, it is maximum. But we have seen the current has changed its direction. If this is towards the positive side, then that would be towards negative side. So at theta equals to 270 degree, it is towards this side, the negative maximum side of the EMF. At 360 case is similar to that of the 0 degree. So at 0 degrees, if EMF is 0, then again at 360 degree, it would be 0. So this changes is again not abrupt but gradual. So let us just join these these points to form a graph. So this is the graph of the EMF. So this is the graph for the EMF generated. Now, if it is forming a positive cycle like this and a negative cycle like this, we can say this has formed an alternating current which has changed its direction, which is also evident from this case. So it means the output that we have got from the generator is alternating current and not the direct current. From where it is symbolized? From the direction of the flow of current. Here direction is B1 to B2 and then after some time the direction is B2 to B1. It means it has changed its direction. We have plotted a graph and we have seen, yes, the current has changed its direction and it is always changing its magnitude. Here it is less, again becomes maximum, less, 0. Maximum in opposite direction, again it becomes minimum and it will continue to form its curve as long as this generator is in motion. So this was all about the AC generator and its working. This is very important concept. So in the next video, we are now going to start with the last part of the chapter, which includes the transformer.